All right, section 5.2, we're doing integrals. We're looking at integrals that are going to involve an ln generally. Integral of 3x squared divided by 5 minus x cubed dx. What would you do? U sub. And generally when you do u sub, u is going to be? The bottom. Usually when you have a fraction, u is the bottom, but not always. Du would then be? Negative 3x squared dx. So then what? Right, we have almost the right thing. We have a negative 3x squared here. We have a positive 3x squared there. So I need to sneak in a negative sign. And the penalty for sneaking in a negative sign is I got to put in another one to balance it out. So that becomes minus the integral of 1 over u du. So that's minus, what's the integral of 1 over u? Natural log, absolute value of u plus c. Full final answer would be minus ln, absolute value, 5 minus x cubed plus c. The integral from e to e squared of 1 over x ln x. What to do with that one? U sub, yeah, these are almost always U sub problems. You might remember on the very first day I told you that you would use U sub practically every day. U is? This time it's just natural log of x. It's not the entire denominator. Why do you want u to only be the natural log of x? Then du will be the rest of your problem, won't it be? Du will be 1 over x dx. All right, on that review sheet that you took home and you turned in, I noticed that when a lot of you are doing u substitution, you are not changing your bounds of integration. When you do u substitution, you have to change your bounds of integration. How come? Because this e and this e squared, these are x numbers. When I do my u substitution, I now have the integral of 1 over u du. So I need u numbers, not x numbers. Okay? So if you do a u substitution, you absolutely have to change your bounds of integration. So I take e and I plug it in here. What's the ln of e? 1. So this bound changes to 1. And then I take e squared and I plug it in. What's the ln of e squared? 2. So those bounds change to be 1 and 2. What's the antiderivative of 1 over u du? Natural log absolute value of u. I'm going to be a little bit lazy. I'm not going to bother writing the absolute value this time because I don't need it. How come I don't need it? Because I'm only plugging in positive numbers, aren't I? So I don't need it. Is it wrong to write it? No. Plug in my numbers. ln2 minus ln1. My answer is ln2. Questions on that one? All right, one more of these. How about the integral of 1 over 1 plus the square root of 3x dx? Any thoughts on that one? Should u just be the square root of 3x? think that would work, but I think there's a better one.
3x.
Not 3x. That wouldn't be wrong, but you'd have a lot more work to do still after that. I think a good idea to try is let u be the whole bottom. Because if possible, I want to end up with 1 over u. I don't want to have 1 over 1 plus u. That doesn't do me as much good, does it? You could make it work from there, but I think it's better to let u be the whole bottom. But you're going to run into some interesting problems with this one. Du then becomes, what's the derivative of 1 plus the square root of 3x?
1 half times 3x to the negative 1 half times 3.
Dx. Perfect. You got to use the chain rule. The derivative of 1 is 0. That's the easy part. Chain rule says you bring the 1 half down. You leave your inside alone. Subtract 1 from your power. Take the derivative of the inside. So I have a problem. And my problem is I can deal with the 1 half and the 3, can't I? Those aren't an issue. Those are just numbers. This thing doesn't show up over here. So what do?
You can multiply by that.
I can multiply by that, sure, if I want. So I'm going to multiply by 3x to the positive 1 half. Because then the negative 1 half and the positive 1 half will cancel each other out. All right, so I'm going to multiply by 3x to the positive 1 half du equals, this would be 3 halves dx. Still got a problem, don't I? I mean, I can fix the 3 halves. I can say, well, the 3 halves is no problem. I can sneak a 3 halves in right here. And then I got to balance it off by putting a 2/3 right there. But I can't put u's in down on the bottom and still have x's here up on top. Getting close, though.
Square both sides.
I don't want to square both sides. I don't want to have a dx squared. I don't have a dx squared there.
Do we want to solve for that?
Close. Solve for square root of 3x. What's the square root of 3x? U minus 1. So that's what I'm going to do with that. So this is one of those kind of double substitution problems that you did in Calc 1. But when you did them in Calc 1, you only ever dealt with linear terms. Once in a great while, this same trick will work with non-linear terms. So the square root of 3x, that's exactly the same as 3x to the 1 half. So I'm going to replace that by u minus 1. So u minus 1 du is 3 halves dx. So this 3 halves dx right here, that's going to be u minus 1 du. And then this thing down on bottom, 1 plus square root of 3x, that's just u. And then I still have that 2/3 out front. That's an unusual type substitution, one that doesn't happen very often. But every now and then it does. So I've rewritten my integral. Now I have everything with u's in it. Can I integrate u minus 1 over u? Yes, no, maybe? How about if I were to write it as 2/3 integral, what's u divided by u? 1 minus 1 over u du. That's 2/3 times, what's the integral of 1? It's just 1u minus, what's the integral of 1 over u? Ln absolute value of u. Finally, I plug my x's back in. Final answer, 2/3 times 1 plus the square root of 3x minus ln, absolute value, 1 plus square root of 3x, plus c. That's probably the hardest problem in the section, would be my opinion on that one. Once in a while that's going to happen where you have to do that. Do your substitution, you end up with some piece that looks like you can't get rid of, but you go back to your u and you solve for that piece and you plug that in also. Questions on that?